Hello friends, welcome back. So let's analyze transport layer using Wireshark. So here on my screen you can see Wireshark and the traffic from Wi-Fi network adapter is being captured. So let's start the capture on the Wi-Fi. So here I have a test website that I'm going to open. So let me open the test page. So this is the login page of the test website which I have loaded for the demonstration. So let's check the IP address of this particular site. So we can do this by opening the inspect panel. You can go to network and now let's reload the page again. So this is the login page. So if I click here, I can see the IP address, the remote address of that server, and the IP that my browser was connected to was this one, and currently the site uses port 80. So you can see that the page was loaded using port 80. So let's go back to the Wireshark, stop the capture, and now to filter out the traffic that was sent to the test URL, I am just going to apply the filter IP addr equals and I'll paste the IP address. So I have removed the port. So if I hit enter, you can see that my computer 192.168.1.105 has connected to the website using this particular IP. So if I right click, go to follow and click the TCP stream, I can see that there are many transactions that have happened while I opened the URL. So whatever you see in the red color is the client requests and the blue one is the response that was received from the web server. So as simple as that. So the first request was the get request, right? When it came to actually accessing that particular site. So let's analyze this with the help of the filter that we have applied. So if I look at the first request that was originated from my computer, so 192.168.1.105 is the IP address of my computer. If we go to the IP config, you will see that this is the IP address of my local computer, and the IP address of the website we have captured, and the same was applied in the filter. So now if you see the first three packets here, so the protocol used is TCP. So first, when I accessed the website or opened the URL in the browser, the request was originated from my computer to the web server. Protocol used was TCP and source port was 62967 and the destination port was 80. So this was the SYN request that was sent. Sequence number 0, window size 64240, length of the segment 0. So many more in-depth options are visible here. So this was the request originated from my computer to the web server. Now this was the SYN. Now upon receiving the request from my computer, the web server replied back with a SYNACK, right? You can see that first SYN was sent, the synchronization request, and the synchronization acknowledgement was received. So this was received from port 80 on the server to the source port on which the request was sent. Sequence number 0 again and acknowledge 1. And in the next phase, the client has responded back to the server with an acknowledgement that I have received your response and now I'm confirming that yes, I have received the response. So it's a three-way handshake that has happened on the test website. And now It is time when the client computer requested for the HTTP page, the login page which was loaded. So this is the protocol used was HTTP, a GET request. So whenever a client or whenever we access any particular web application, what happens is there is a GET or POST method that is used. There are many methods available, but just for your clarity for now, whenever we request for some resources from the web server, it's a GET request. When we submit something, it's a POST request, right? So I'll start the capture once again, and now I'll go to the test page and I'll enter some dummy credentials. I'll log in. Now I did something on the web page. Now if I go back and stop the capture, and now I filter out IP ADDR, the same IP address, hit enter. Now here you can also see the post action that has happened. The page was already loaded, but I did not capture the loading time, right? I did not capture the site while it was loading. So I don't see any get action happening here. I can only see the post action, right? Let's do that once again. So what I'll do is I'll close this. I'll go back to the login page. Right now, what I'll do is I'll first start the capture. Start the capture, continue without saving. I'll load the page now again. Now I'll enter some credentials. Hit enter and done. Now let's stop the packet capture. Earlier we did not see any get, it was only the post as you can see here. Now I'll filter out the traffic once again. Now you can see that the get request is also visible here, right? So get is there, post is there. So get means the website was loaded from the web server to your browser, and when you submit the or click the login button, so it was a submit action, that is the thing, but the post action that was done on the website, right? So TCP handshake we already discussed. Now let us see the HTTP protocol details here. So my computer sent a request to the destination URL. The protocol used was HTTP. It was a GET request. Now if I scroll it upwards a little, now if I go to the transmission control protocol, here you can see the HTTP GET request was sent. Source port used was 63168. The destination port was the port 80. So what transport layer does is it does the job of end-to-end connectivity. So that's where we call it as the heart of the OSI model, right? So end-to-end connectivity, when we say end-to-end connectivity, it is nothing but port to port connectivity, right? So there could be 100 computers on this side of the network, 100 computers on the other side of the network, and one of those computers from source and destination are talking to each other. Then the mapping of this particular end-to-end traffic is done with the help of source and destination IP address at the network layer, but the port is used to identify the source and the destination, right? Now consider it's a web server. It has to run on a certain port. It will run on port 80 or 443, either of these two ports. Now HTTP is now insecure. So 99% of the websites today run on port 443. So the destination port is not going to change, but how the client is being identified is this source port. So that's where you can see a random port that was used. Now here in the GET request, if you look at the TCP segment length was 527, sequence number was 1, and the next sequence number, that is the relative sequence number, is 528. Now now the acknowledgement number is 1, and there are many more options visible. That the window size was 1020, right? So now if I click on the next packet here, it was the response received from the web server on my browser, that is my computer. And this was SYNAC sequence 0 acknowledgement 1. As you can see here, in the previous one, the sequence number was 1, next sequence number was 528. Moving to the next packet, sequence number was 1, and there was an acknowledgement for 1 again, right? Now if we move to the next, now the client computer is talking to the web server. Here you can see the sequence number is 1, and the next sequence number is again 1 here. Window size is 1025. Now here the web server has now responded back with HTTP 1.1 200 OK. So what that means is, now here you can see the acknowledgement number 528, right? So if you go back to the GET request, here also you will see the next sequence number that was highlighted was 528. And this is the response that the web server has given to the source computer. So now moving next, a TCP request was sent from 1.105 to the web server again, sequence number 528, and the acknowledgement number is 679, right? Now if I move to the next packet, here next sequence number is 1238 and the acknowledgement number is 679. Moving next, now the acknowledgement number is 1238, right? And the next sequence number is again 768. Moving next, you will see that there is an acknowledgement coming in from 768. So here it's a to and fro communication, and there is a sequence number being created and there is an acknowledgement against that particular sequence number. So this is how the communication happens on the transport layer. As we also discussed about the windowing, right? The data transfer that can be done between the source and the destination is, it's a continuous check that happens here, right? And basis the acknowledgement from the destination, the source then decides the size of the window that can be used to transmit the data. So friends, I think you have got enough idea on how this is happening. uh, Now, this is a completely unencrypted traffic that we have analyzed because the destination server was using port 80. But if the destination server uses port 443, then he won't be able to see all these details, as the traffic would be in encrypted manner, right? But there are many ways. One of the best possible option is you need to have that certificate with you, the private key, and then while you analyze the traffic from the secured website, you can then redirect the logs that are the packets that you capture on the Wireshark to some folder, and then you can decrypt those packets to analyze them in the same fashion that we have done. So the Wireshark decryption, the packet decryption on an HTTPS site, I have covered that in my Wireshark course. But for now, it is important for you to understand that the transmission that happens between the source and the destination, happens in this particular fashion. So for the network layer, we need not to go back again to Wireshark because the source IP, destination IP is clearly visible to you here in this packet analysis itself. So I will not be covering any separate Wireshark session for the network layer. But what you can see here, for the data link layer, here you can see the frame that uh, the transactions that happen between the source and destination, these are captured, and you can see the MAC addresses of the source and the destination, which are very well visible here. So my computer is not directly interacting with the web server. So when it comes to frame, when it comes to data link layer, it is the MAC level communication that we can see, and my device is directly interacting with the broadband router that I have at home, right? And so that is the ZTE modem for which it is showing the MAC address. So in the same way, uh, you can see source MAC address is being captured here. And if I go to internet protocol, the version of IP that I'm using is IP version 4, and the IP address of my computer is visible here, and the destination IP address is 163.182.194.25. So it is the same destination IP to which the browser from my computer has connected. So again, the protocol used was TCP, so that's where port number 6 is visible, right? So if it is UDP, you know the port number that is used by the UDP, and we have already discussed that in the previous session. So that's all about the analysis for the demonstration of OSI model. So in the next session, let's talk about the network layer. We have already discussed about the Wireshark packet analysis for network and data link here itself. So with this, friends, I think it's pretty much clear to you on how to analyze traffic for the transport layer using Wireshark. So with this, we come to the end of the session. Thank you for watching.